All right. Good afternoon and welcome to Master Talker online class. If today is your first day of watching our video, please consider subscribing. So we are still talking about probability. Probability. Now, in this video, we'll be talking about binomial probability distribution. Okay, binomial probability distribution. Binomial probability distribution. Okay, so in binomial probability distribution, you need to know some certain things. You can go and read up the definition of discrete continuous random variable. Discrete random variable, continuous random variable. In fact, what is a random variable? What is discrete random variable? What is continuous random variable? So these are the small things you need to know. Now, in probability, normally in my video, I did a video on binomial expansion. And for if you want to expand something, binomial means 2. For example, I want to expand p plus q. For instance, I want to expand, okay, raised to power n. You want to expand this. The formula is simply the summation of r starting from 0 to that n of n combination r, p raised to power n minus r, q raised to power r. Okay, and that is how we expand. Okay, or yeah, that is how we expand. So we're having this, and don't forget that n combination r means n factorial all over r factorial, then n minus r factorial. These are the things you need to know. Okay, but in binomial, the probability of what? X, which is equal to r. Now the probability we are getting is the probability of r. Okay, is equal to what? N combination r, p raised to power, not n minus r again, please. P raised to power r, then q is the one that is raised to power n minus r. Please note that here they swap it. Okay, they swap it here, so that you don't make mistake. Very important formula. Okay, so let's solve an example for you to understand what I'm trying to say. And don't forget that how do you get your p? That your p ranges from what? 0 to 1. P ranges from 0 to 1. Then my q is simply 1 minus p. Don't forget that. Okay, so let's solve a question. They say 4 out of 4, F-O-U-R, 4 out of every batch of 16 manufactured articles, okay, are defective. Then let's say if 4 articles are picked at random, if 4 articles are picked at random from the batch, okay, if 4 articles are picked at random from the batch, comma, then I say what is the probability, okay, that they contain, I exactly 2 defective article. Number 2 said not more than 1 defective article. Okay, so let us solve this. It's very simple. It's very simple. So let us solve it. So in this one, I'm having solution. Let me show you how to get this solution. Okay, now this is we are looking the probability. Write your formula first. The probability of x being equal to r. We are looking for probability of r. That the formula is what? N combination r, p raised to power r, then q raised to power n minus r. Okay, don't forget that here they swap. But in normal binomial expansion, it is p raised to power n minus r, then q raised to power r. Okay, So having this, to get your n, to get your n, my n is simply how many are they talking about there? They are talking about 4. Okay, look at that. If four articles are picked, so how many did we pick? We picked 4 articles. So my n is 4, but the probability of the people that will be defective is what? 4 out of 16 are said to be detected. So 4 out of 16 are defective, so which is 1/4. I've gotten my p. So my q is now 1 minus that p, okay, which is what? 1 minus 1/4, okay, which is simply 3/4. So let us now pick it. R is gotten from the question. They said exactly 2. They say find the probability of exactly 2 being defective. So what I'm looking for here is R is now 2. So I'm looking for the probability of that 2. Okay. Let me just write the probability of R being equal to 2. And my R is 2 now. So probability of what? X being equal to what? 2, because my R is 2. So it's equal to what? N is what? 4 combination 2. My P is 1/4 raised to power 2. Then 3/4 raised to power 4 minus 2. So what do I have now? This is 4 factorial all over 2 factorial, then 4 minus 2 factorial. So I'm having here what? 1/4 squared, then 3/4 raised to power 2 again. So my answer, everything here will give you 6. So try it. 4 factorial all over, this one will be 2 factorial, then this minus this will still give you another 2 factorial. So 4 factorial means 4 times 3 times 2 times 1 all over. This one means 2 times 1 times another 2 times 1. So 2 times 1, take care of 2 times 1. 2 here, 2 here, 2 times 3, 6. So everything here is giving me 6. In fact, in your calculator, just press it direct. Press it 4 combination 2, you will get 6. Okay? Then bracket times 1/4 squared. 1/4 squared will give you 1/4 squared will give you what am I saying? 1/4 squared will give you 0.0625 times 3/4 squared will give you 0.5625. So if you multiply everything, you're having 0.2109. Okay, as simple as that. So now let us do the second one. Now for the second one, they said in the second one they're talking about, they said not more than 1. Not more than 1 means the probability of, it's either they can get 0 that are defective, or they will get just 1 that are defective. So it's the probability of what? 0 or 1, which is now what? So let us now get it, which means n is 0 in the first one, then in the second one n is 1. So this is equal to what? R is 0, and then in the second one R is 1. So I can just say it's the probability of 0 plus the probability of what? 1. So which is what? Probability of 0, you will now have what? You are supposed to have a n is what? 4. Okay, 4 combination 0, then I'm having 1/4 raised to power 0, then 1/4 raised to power 1/4 raised to power 4 minus 0, then 3/4 raised to power 0. Don't forget the formula. So I'm going to have everything here will give me 1. Okay, 1 times this one, 1/4 raised to power 4 will give me 0.3164. Okay, plus okay, sorry, this is equal to, let me talk about this one. My formula is n combination r, p raised to power n minus r, sorry, p raised to power r, then q raised to power n minus r. So that is that. So let's go there now. And our r is 0. So I'm having 4 combination 0. My p is 1 over what? Don't forget, my p is 1/4. So 1/4 raised to power 0, and then 3/4 raised to power 4 minus 0. That is for p of 0. Plus p of 1 will now be 4 combination 1. Okay, 1/4 raised to power 1, then 3/4 raised to power 4 minus 1. So if you do everything here, you are having this one will give me 1 times anything raised to power 0 is still 1 times this one will now be 3 over 4 raised to power 4. 3 over 4 raised to power 4 will give me 0.3164 plus this one will give me 4. 4 combination 1 will give me 4. Press it in your calculator. Times 1 over this raised to power 1 will give me 0.25 times this is raised to power 3. 4 minus 1 is 3. So you now have 0.75 raised to power 3, which is, or let me write that this one is raised to power 1, and this over this means 0.75 raised to power what? 3. Raised to power 3. Raised to power 3. So if you multiply everything here, you're having 0.3164 plus multiply everything here, you're having 0.4219. Okay, so if you now add, you're now having 0.7383. Okay, so that is that. So you see, this is very, very simple. This is very, very simple. So don't worry, when I solve the next question, when I solve up to 3 to 4 questions, you will understand. Now the next one, let's look at the next problem. The next one said a survey shows that 60% of families 60% of families in a certain area have television sets. Okay, have television sets. Then find the probability that among 16 families randomly selected, okay, in that area, A question said 14 of them will have television. Okay, B question said at least 14 will have television. C question said at most 13 will have television. D question said 13 or 14 have television. Okay, solution. Okay, this is very, very simple. Now they say that in a survey shows that 60%. So I've gotten my P. My P simply means 60%, which is what? 60 over 100. 0 cancel 0. 2 here, 3, 2 here, 5. So I've gotten my P to be what? 3 over 5. And then my Q is simply 1 minus P, which is what? 1 minus 3 over 5, which is what? 2 over 5. I've gotten my Q. Then the people that are now selected from that area is 16. So my N is simply what? 16. So what I'm looking for now is my R, and my R is gotten from the question. So A now is now the probability of what? 14. Okay? Don't forget the formula that P of X, which is equal to R, is equal to what? N combination R, P raised to power R, then Q raised to power N minus R. Okay? Don't forget that. So the probability of this is equal to 16 combination 14. Okay? My P is what? 3 over 5 raised to power 14. Then 2 over 5 raised to power 16 minus 14. So what do I have? 16 combination 14 will give me 120. So 120 bracket 3 divided by this will give me 0.6. 0.6 raised to power 14, and 2 divided by this will give me 0.4. 0.4 raised to power what? 2. Okay, so if you do everything, you are getting 0.01505. Okay, so if you multiply everything, that's what you will get. As simple as that. Number B said at least 14. Okay, at least 14. That is at least 14. At least probability of, which one is at least? Okay, at least 14 means probability of 14, that is 14 and above, plus probability of 15 plus probability of 16, and that is what it means. So let us get that. We have gotten this one, but let's just put it. I have 16 combination 14, 3 over 5 raised to power 14, then 2 over 5 raised to power 16 minus 14. That's for the first one, plus, then for 15, 16 combination 15, the same 3 over 5 raised to power 15, then what am I saying? Then 2 over 5 raised to power what? 16 minus 15, plus the last one, 16 combination 16, 3 over 5 raised to power 16, then 2 over 5 raised to power 16 minus 16. So if you do that now, you'll be having, let me continue here, okay? If you do that now, you will be having that for B solution. That for B will now be 16 combination 14. In fact, we got this one to be 0.01505, okay? Plus, so do this one, you will get if you do that one, you will get 0.003009, okay? Plus, do the last one, you will get 0.0002821. So if you add everything, you are having 0.01834, okay? That is that. So let us do question C. Question C said at most 13, and at most 13 means that 13 is going to be the highest, which is what am I saying? At most 13 means you have to find 1, 2, 3 up to 13. But instead of finding 1, 2, 3 up to 13, just said that at most 13 is the same thing as saying 1 minus at least 14. Yes, because at least 14 means that the least you are getting is 14. Okay? Is it at least 14? I be at least 13. At most 13. That is 13 down. Okay? At least 14. Okay, let us check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, at least 13 means from 1 to 13. So instead of getting from 1 to 13, but at most 13 is from 1 to 13, then at least 13 is from 14 to this. So instead of getting all this one is too long, just say 1 minus these people. So 1 minus at least 14. Okay, this one is too long. So have we gotten at least 14? Yes, we got at least 14. So my answer will now be 1 minus this thing we got 0.01834. So which will give you 0.98166. Okay, then number D said 13 or 14. 13 or 14 means probability of 13 plus probability of 14. Okay, so probability of 13 and probability of 14, what do you do? That is what? 16 combination 13. What did we get? 3 over 5 raised to power 13. Then 2 over 5 raised to power what? 16 minus 13. Okay, plus the same thing here, 16 combination 14, 3 over 5 raised to power 14, then 2 over 5 raised to power what? 16 minus 14. So if you do that, you are going to get 0.04681 plus 0.01505. So if you now do it, you're having 0.06186. Okay, so that is that. You see, it's very, very simple. So once you know how to set it like this, it's not difficult. press 16 combination this, you bring it down, times press this over this raised to power this, you bring it down, this over this raised to power the next one, you bring it down. So it's very, very simple to get. So let's solve more calculation so that you will understand better. Okay, this one said if x denotes the number of heads in a single toss, okay, of 5 fair dice, okay, 5 fair coins, okay, comma, of the same size, find 1, probability of x being equal to 1, II, probability of x being less than 3, okay, solution. Okay, so this is very, very simple. Now, you know, when you throw a coin, you are going to get either a head or a tail. Okay, you are going to get either a head or a tail. So they say that if x denotes the number of heads, x denotes the number of heads in a single toss of 5 fair coins of the same size. Okay, so now it means that the probability might be is 1/2, because this is the probability of getting a head. So Q will now be, if you don't get a head, you get a tail, and probability of getting a tail is simply what? Is simply 1/2 again. So because the only thing we have to get is either head or a tail, and probability of getting a head is 1/2. So Q will now be probability of getting a tail, because that is the only outcome that we can get in throwing a coin. But the number of coins we are throwing is now 5, not just 1. We are throwing 5 coins. So the first one said P of x being equal to 1. Don't forget our formula. Our formula said that P of x being equal to R is equal to n combination R, P raised to power R, then Q raised to power n minus R. So let us follow this. If you follow this, we are going to have 5 combination 1. 1/2 raised to power 1, then 1/2 again, 1/2 again raised to power 5 minus 1. So I'm going to have that this is equal to 5 combination 1 is 5. So I'm going to have 5 into 0.5 raised to power 1 and 0.5 raised to power 4. So if you do everything, you are having 0.1563. As simple as that. Now number 2 said probability of getting x being less than 3. X being less than 3 is the probability of getting 1, okay, or probability of getting, in fact, probability of getting 0, 1 or 2. That is that. So that is probability of x being equal to what? 0 plus probability of x being equal to 1 plus probability of x being equal to 2. Okay. So if you have that, what do you do? This one will give me 5 combination 0, 1/2 raised to power 0, then 1/2 again raised to power 5 minus 0, plus this one will give me 5 combination 1, 1/2 raised to power 1, and 1/2 raised to power 4. Okay, in fact, let me be doing this straight. Plus 5 because I know that the sum will give me 5. 5 combination, sorry, this is 2. This is 2. 5 combination 2, 1/2 will be raised to power 2, then the other one will now be 5 minus 2, which is 3. 1/2 raised to power 3. So if you do that, you are going to get 0.03125 plus 0.1563 plus 0.3125. So if you add everything, you are having 0.5001. Okay, so that is that. So let's keep solving more questions so that we'll be getting familiar with how the question look like. So the next thing we are going to look at So the next one said, number 3 example said, the probability that automobiles using a certain road will the probability that automobiles using a certain road will have a good time is 0.6. Okay, then they now say if 10 cars are stopped in a random safety check, then I say find correct to 4 decimal places. The probability that a exactly 2 will not have good types. B, at least 8 will have good types. Solution. Now they want to confuse you with that first question, so don't fall into their trap. They want to confuse you with that first question, so don't fall into their trap. Okay. So now solution. Now they said the probability that automobile using a certain road will have a good types is 0.6. Now that is P is 0.6. So my Q will now be 1 minus P, which is 1 minus 0.6, which is 0.4. Okay, I've gotten that. Now if 10 cars, now N is 10, you are done. So the first one is where you are looking for your R. So P of X being equal to what? Okay, they say exactly 2 will not be good, but the 2 not being good, okay, 2 will, in fact 2 not good, don't know how to write it, exactly 2 not good should be equal to 1 minus 2 being good. So which is what? 1 minus probability of 2 being good, because all we are talking about is being good. So we cannot go start getting the one that is not good, so we'll just do 1 minus that. So to get this now, to get the probability of X being equal to 2, will now be equal to what? N combination R, P raised to power R, Q raised to power N minus R. Very simple. Which is what? N is what? 10 combination 2. What do we have? Let me write that this is R, where this is P. X is equal to what? 2. 10 combination 2. Then I'm having 0.6 raised to power 2. Then 0.4 raised to power 10 minus 2. Okay, so what do we have? Sorry, I'm swapping it. It's supposed to be N minus R. Okay, yes, it's correct. So what do we have? 10 combination 2 will give us what is 10 combination 2? You know, I'm not with calculator and I don't like wasting my time. So everything will give us if you do everything here, you're having 0.01062. So then the probability of 2 not good. Probability of 2 not good. Okay, will now be 1 minus 0.01062, which is what? 0.9898932. 938. So they say 4 decimal places 1, 2, 3, 4. So it will now be what? 0.9894 approximately. Okay, so number 2, I can clean here. Number 2, let me bring out my parameters here. Number 2 now, they say at least 8 will be good. At least 8 will be good. That is from 1 to 8. So instead of getting at least 8 being good, you can get that at least 8 will be good. Okay, at least 8 will be good. That 8 will be good, 9 will be good, and 10 will be good. Yes. So at least 8, probability of at least 8 will now be what? Probability of 8 plus probability of 9 plus probability of 10. So what do we have? So just do it. Don't forget that my n is 10. Okay, my p is 0.6, my q is 0.4. So I'm having and my formula still probability of x being equal to r is n combination r, p raised to power r, q raised to power n minus r. So I'm having what? 10 combination 8. Okay, my p is what? 0.6 raised to power 8, then 0.4 raised to power 2, because both of them will give me 10, plus 10 combination 9, 0.6 raised to power 9, then 0.4 raised to power 1. Okay, plus 10 combination 10, 0.6 raised to power 10, then 0.4 raised to power 0. So if you do it now, you are having so if you do everything, you're having 0. The first one is giving me 0.1209 plus 0.04031 plus 0.006047. So if you add everything, you're having 0.167257. So approximately to 4 decimal place, 1, 2, 3, 4. This is more than, this is 5. Call it 1 and put it here. 0.1673 approximately. So that is that. So let's keep solving questions. It will help us to be understanding it more and more and more and more. Okay? Let me check my time. Okay, I think we have tried. So in our next video, we continue. Thank you very much for watching. Please consider subscribing.